Mechanically, there's very little difference between a power steering gear and a manual gear. Even if something happens to the hydraulic part of the power steering system, you still have mechanical control of the car. But suppose we let Bob explain gear operation.
That's my specialty, Tech. Turning the worm shaft of a power steering gear moves the power piston up or down in exactly the same way that the worm shaft in a manual gear moves the ball nut up or down. The cross-shaft sector teeth engage rack teeth machined into the power piston. This arrangement changes up and down piston movement into cross-shaft rotation. Again, this is essentially the same as a manual gear. And as you already know, the cross-shaft moves the pitman arm in an arc, and this motion is transmitted to the front wheels through the steering linkage. From steering wheel to front wheels, the mechanical operation is the same for power and manual gears. However, in a power steering gear, the steering gear housing is also the cylinder for the power piston. The power piston divides the cylinder into two separate power chambers. But we'll have to look at the gear from another angle to see how pressure in these chambers is controlled. The steering valve, mounted on the gear housing, determines whether pressure will be routed to the power chamber above the piston or the chamber below the piston.
But what controls the steering valve?
A pivot lever is the mechanical link between the steering valve and the worm shaft reaction area.
That reaction part of the gear is where I get lost.
Okay, my boy. Let's see if Bob and I can explain it slow and easy so you'll get unlost. We'll use a gear with a left-hand worm. In a right turn, the worm shaft tries to thread its way out of the power piston. As a matter of fact, the entire worm shaft does move upward a very small amount. Can you explain why, Bob?
Sure thing, Tech. The worm shaft thrust bearings and center race are between the cylinder head and the housing head. But there's enough clearance between the cylinder head, center race, and housing head to allow the center race and the worm shaft to move up or down a small amount. So, when the steering wheel is turned to the right, the worm shaft and thrust bearing moves upward. By the same token, on a turn to the left, it moves downward. This thrust bearing movement is used to operate the steering valve. Here's how. The steering valve spool is connected by a pivot lever to the center race of the worm shaft thrust bearing. A ball shape at the upper end of the pivot lever fits into a pocket in the spool valve. The lever pivots on another ball shape and is connected to the bearing by a ball at the lower end of the lever.
It doesn't take much movement of the center race to move the steering valve spool quite a lot. Since the part of the lever above the pivot is about 4 times as long as the part below the pivot, the lever multiplies center race movement about 4 to 1. Well, that just about wraps up the mechanical connection between the steering valve and the worm shaft. Unless you have a question, we'll get into the hydraulics.
I'm all ears, and you haven't lost me yet.
Lands on the sliding spool in the steering valve open or close the ports leading to the power chambers above and below the power piston. As long as the spool valve is centered, both power chamber ports are open the same amount. Pressure is equal in both power chambers and there is no power assist. On a left turn, the worm and center race move downward. This moves the spool valve upward. The lower land closes the lower port to pump pressure and opens it to return flow. The pressure in the power chamber above the piston is reduced. At the same time, the upper land of the spool valve opens the upper pressure port even more. This admits full pump pressure to the power chamber below the piston.
Since there is full pressure below the piston and reduced pressure above the piston, hydraulic pressure pushes the piston upward. This power assist continues as long as the driver turns the wheel and keeps the control valve off-center. When the steering wheel is turned to the right, the control valve moves down instead of up, and the entire power assist process is reversed.
I can understand that easy enough, but the reaction rings and the built-in feel still stump me.
Bob kept it simple on purpose, but now I think you're ready to hear about the reaction springs and the reaction rings. So let's go back and take a closer look at the pivot lever and the center bearing race. The center race, a spacer, and the pivot are actually sandwiched between the reaction springs and the reaction rings. But let's see how this looks in a cutaway illustration.
The reaction springs provide the basic centering force acting on the center race of the thrust bearing. When turning force on the steering wheel is relaxed, the reaction springs center the bearing race and this returns the steering valve to the neutral position. You'll notice that the reaction springs do not bear directly against the center race, but bear against the reaction rings, which do bear against the center race. The reaction springs provide part of the very desirable feel built into the gear, but not all of it. It is the reaction rings which provide the resistance or feel that is proportional to the total steering effort required to steer the car. The resistance of the reaction spring is always the same, but the resistance provided by the reaction rings depends on the actual steering effort called for. Hydraulic pressure from the lower pressure chamber acts on the lower reaction ring. Pressure from the upper power chamber acts on the upper reaction rings. However, when the steering wheel is turned and the steering valve is moved off-center, there is more hydraulic pressure against one reaction ring, less against the other. This extra pressure resists steering wheel movement to provide excellent steering feel.
Why are there two reaction rings above the center race?
The two upper reaction rings correct an inherent unbalanced hydraulic condition in the steering gear. If it weren't for the extra reaction ring above the center race, the car would try to self-steer to the right.
You'll find a detailed explanation of those unbalanced forces in the reference book. Before we sign off, let's see what tips Bob can give us on power steering diagnosis.
The first step is to figure out whether the trouble is in the pump or the gear. If there is no assist in either direction, the trouble is probably in the pump. At least it is probably lack of pressure or flow. The obvious things to check are belt tension and fluid level. If the trouble is in the pump, the first thing to check is the valve. Remember, if the valve sticks, it will stick open. That's because pump pressure opens it and spring pressure isn't great enough to close it if it's dirty or burred. Foreign material in the gear or pump is the greatest single enemy of the power steering system. It's impossible to overemphasize the importance of cleanliness when servicing the pump or the gear. The only safe way to remove scratches or slight burrs on the valve spool is to carefully rub the spool against a piece of crocus cloth laid over a flat surface. Remember, that spool is a selective fit in the pump body, and all you want to polish out is the burred metal. Self-steering, or unequal assist, on right and left turns is most apt to be the result of control valve sticking or of misadjustment of the valve. To adjust the valve, I simply jack up the front of the car so the wheels clear the floor. Then I back off the steering valve body screws and retighten them to about 7 foot-pounds. With the engine running, tap the steering valve assembly up or down until there is no self-steering. Then, tighten the valve body screws. Don't turn the front wheels against their stops before you retighten the valve body screws or you'll blow out the O-rings. When adjusting the valve, tap the control valve body screws to move the valve up, the end plug to move it down. Do not tap on the control valve or the steering valve body. Lumpiness or binding is usually not in the gear, but in misalignment of a steering column. Whatever you do, don't force the floor plate in order to start the plate attaching bolts. If you follow the procedure in the service manual, you won't have any trouble on this score. The lower end of the steering shaft must be centered in the coupling so that the gauge hole is 13/16 of an inch above the coupling. An uncentered coupling can cause lumpiness, wander, and returnability problems.
I'm sure glad I asked you about that new pump. I wound up getting a liberal education on pumps and gears.
You'll find some additional information on diagnosis and service in the reference book, Joe. I hope you fellas out there will give your reference books the once-over now and keep them handy for future reference. And don't overlook the information in your new service manuals. They have all the service details on the new pump.